Easy baby, voila. Eh. Whiskey, do you want mama? Yes, welcome. Let's look at this JAMB past question chemistry for 2018. Question number 1. The periodic classification of the elements is an arrangement of the elements in order of their A. Atomic weights, B. Isotopic weights, C. Molecular weights, D. Atomic numbers. Now, for us to understand this very well, we need to first of all know what the periodic table is, where we have the periodic classification of the elements. So what is the periodic table? So by definition, the periodic table is the arrangement of elements in order of increasing relative atomic masses or relative atomic mass. That is what the periodic table is. The periodic table is simply the word arrangement of elements. You have a table like this, where you have elements arranged in the periodic table. Now, what is actually happening in this periodic table? In this periodic table, the elements similar properties they will always keep on reoccurring or recurring at regular intervals. And these regular intervals is called periods. Regular intervals or period. So that is what happens in the periodic table. So we have the periods and the groups. So the periodic table is actually the arrangement in the order of increasing atomic mass. So how do you get the atomic mass? You know that the atomic mass is a function of the atomic numbers. So the atomic mass is a function of the atomic number. So from that, you can easily say that the right answer should be the atomic numbers. D should be the correct answer because as the atomic number is increasing, the mass number is also increasing, or the atomic mass is also increasing. So you find out that something that has the atomic number of 6 will have the mass number or atomic mass of 12. One that has 8 will have the this of 16. So you have this type of increment. So actually the periodic table is arrangement due to the atomic numbers, or you call it atomic masses. So that is the correct option, the D. And also you should know that the periodic table is the arrangement of elements in the order of increasing relative atomic masses. And the elements with similar properties will keep on increasing at regular intervals called periods. Now it's also important to know that the atomic number is the number of protons in an atom. Whenever you hear the word atomic number, what does it mean? Atomic number is the number of protons in an atom. That is what atomic number is. So when you have an atom, it will have a nucleus, and inside this nucleus you have the protons as well as the neutrons. So the revolving around the nucleus is the electrons. So the number of these protons is known as the atomic number. Understand? So you find out that if you have an element with atomic number of 1, you're going to have the one of 2, you're going to have the one of 3. So something like that. So you have these arrangements in the periodic table is actually according to their atomic numbers. Or in this case, you have atomic masses. And atomic masses is also a function of the atomic number. So it is not atomic weight, it is not isotopic weight, and it is not molecular weight. So the right option is the atomic numbers. Thank you. Hello, welcome. Let's look at this JAMB past question for chemistry 2018. Question number 2. If 1 liter of 2.2 molar sulfuric acid is poured into a bucket containing 10 liters of water and the resulting solution mixed thoroughly, the resulting sulfuric acid concentration will be A. 2.2 m, B. 1.1 m, C. 0.22 m, D. 0.11 m. Now, whenever you see a problem that concerns solution formation, solute inside a solvent, whenever it involves solution formation, the general formula that is used is Ca Va, that's concentration of A, that is one of the components, times its volume, all over concentration of the other one times its volume, equal to number of moles of the first one all over number of moles of the second one. So this is the formula that you use whenever you see similar calculation to this. Now, what is our Ca in this Okay, Ca is the concentration of the sulfuric acid, and it's giving us 2.2 mole. Now, what is Va in this case? We are taking the acid as A. So, volume of the acid in this case is 1 liter. Now, what is Cb? Which is the resulting concentration when it is thoroughly mixed, which we don't actually know. Now, what is Vb? Which is volume of the water this time around, which is, we are giving as 10 liters. So we have 10 liters. Now, what is the number of moles involved? If you write the chemical equation, you will find out that Na is 1 and Mb is also 1. So having this, if you fix this in this equation, Ca, we already know is 2.2. So we have 2.2 times Va is what? 1. All over Cb is what? Cb we don't know, so we still write Cb times Vb is what? 10, equal to 1 over 1, which is 1. So if you make Cb the subject of the formula, we have Cb equal to, if you cross multiply, you have 2.2 times 1 times 1 all over 10. So this will give us 2.2 over 10, which is 0.22 m. So that is the value of our Cb, and that is C is the right option, 0.22 m. So the most important thing that you need to go away with in this very solution is that once you have something that involves mixing sulfuric acid being poured into water, checking the concentration, you need to use this formula. This is the general formula for calculation. So all this will be given to you. If you want to get this, you can simply write the equation of the reaction so that you see the number of moles. So if you have A reacting with B to form C plus D, so you see that the number Na here is 1, because if it is 1, it's not written. Nb, this Nb here is also 1. But if you have 2 here, then this thing has to be 1 over 2. If you have 3 here, then it can now be 3 over 2. So it depends on what is in front of this molecule that you call your Na and Mb. So that's how you locate your Na and Mb. So that is it for this. Thank you. Hello, welcome. Let's look at this JAMB past question, Chemistry 2018, question number 3. In the above experiment, Fig 1, the litmus paper will initially A. be placed, B. turn green, C. turn red, D. turn blue. So this is the actual experiment in this Fig 1. This is actually a damp neutral litmus paper. It's placed on top of this tube, and this is a porous asbestos plug. And right inside this tube, we will have solid ammonium chloride, and it is being heated to a temperature of 350 degrees Celsius. So when you heat this ammonium chloride to this very temperature, it will release ammonia gas. So what will ammonia gas do to a damp neutral litmus paper? Ammonia gas, you know, is an alkaline gas, so it will naturally turn the neutral litmus paper to blue. So the actual answer to this problem is that it will turn it to blue. D is the answer. Because why? With the experiment that we are looking at, ammonia gas is going to be formed. And we all know that ammonia gas is an alkaline gas. And what does alkaline do to a litmus paper? It turns red litmus to what? Blue. So that's what will happen. So that is why D is the answer to this. So in this, basically we need to know what is going to form. When we look at this sketch very well, we are going to find out that when solid ammonium chloride is heated at this very temperature of 350, ammonia gas that has a characteristic choking smell which is easily recognizable is released. So you can actually find this topic under nitrogen and its compound, and you can actually check test for ammonia. When you check for test for ammonia, you'll be able to understand this very well. Test for ammonia, then you'll see this. So this topic is under nitrogen and its compounds in your chemistry textbook. So what you're considering here is sodium chloride. So whenever it is heated, ammonia has to be liberated, and this ammonia turns this very litmus paper to blue, and that is why we have this as your answer. So the right answer is turns blue, D. Thank you. Now let's look at this problem for JAMB past question chemistry 2018, question number 4. A correct electrochemical series can be obtained from K, which is potassium, sodium Na, Ca calcium, Al aluminium, Mg magnesium, Zn zinc, Fe iron, Pb lead, Hg, Cu, Hg, Au by interchanging. So what do you interchange in order to make this to be the correct electrochemical series? Now, if you look at the electronic configuration of these various elements, which actually determines their arrangement in the electrochemical series, you will find out that aluminium comes before potassium. So this very Al comes before potassium, which is K, and then magnesium comes before aluminium. So now, let me write the right arrangement that we are supposed to have for the electrochemical series. We are supposed to have H, then Na, then Mg, then Al, then K, then Ca, then Fe, then Cu, then Zn, then Ag, then Au, then Hg, then Pp. So that should be the right arrangement. And now, having this arrangement, you can see that the right interchanging should be A, where you have Mg coming before Al. So we have to interchange this so that we are supposed to have Mg before Al and not the other way. So if you interchange this Al coming before Mg to Mg before Al, then we are going to have the right electrochemical series this time. So you can check this under electrochemical series so that we'll see this right arrangement. Hello, welcome. Let's look at this JAMB past question chemistry 2018, question number 5. A basic postulate of the kinetic theory of gases is that the molecules of a gas move in straight lines between collisions. collisions. This implies that A. Collisions are perfectly elastic. B. Forces of repulsion exist. C. Forces of repulsion and attractions are in equilibrium. D. Collisions are inelastic. Now, for us to understand this and be able to answer it, we need to know about the kinetic theory of gases or matter. Now, the kinetic theory of matter or gases actually postulates that these particles, that is the particles of the gases, are continually, if you check your textbook, you're going to find this out, continually moving. The particles of the gases are continually moving, and therefore, so they possess kinetic energy. So that is the postulate. So according to the assumption of kinetic theory of gases, they actually move in a straight line between collisions. The gas molecules will collide with one another and with the walls of the container. So what actually happens is that if you have gas molecules, they are constantly colliding with one another, and they're also colliding with the walls of the container. That's what is happening. That's what the postulate of the kinetic theory of gas says. So they constantly do that. So there is the force of repulsion that exists between them. There is force of repulsion existing. So this force of repulsion also enables this collision with the walls of the container and with them. So if you check out things like the Van der Waals force, the Van der Waals equation for solving gas movement, you're going to find out that there is space for correction due to volume and correction due to force of repulsion, A and B. So all these tends to point towards these forces of repulsion exist. Whenever you talk about kinetic theory of gases, you must mention the forces of repulsion that exist between the molecules, which enables pressure to be created due to the collision with the walls of the container. So if you go by elimination, perfectly elastic is not there. If you check the kinetic theory of gases, that's what we are looking at. So the postulate of kinetic theory of gases is that the particles are continually moving, and so they possess kinetic energy. Now, what actually happens is that the gas molecules will collide with one another. So there is always collision of gas molecules with one another, and also with the walls of the container. So that's where collision normally happens, with one another and with the walls of container. And there is always force of repulsion existing. If you check the Van der Waals equation, you see where this correction for force of repulsion is taken care of. So B is the accurate answer. But take note of the postulate or the statement of the kinetic theory of gases. That the gas particles are in continual motion, and so they possess kinetic energy. And as they are moving in this very motion, they are colliding with one another and with the walls of the container. Thank you. Hello, now let's look at this question number 6 for JAMB Past Question Chemistry 2018. On which of the following is the solubility of a gaseous substance dependent? I. Nature of solvent. II. Nature of solute. III. Temperature. IV. Pressure. Option A. I, I, and IV. B, I, and I only. C, I only. D, I, and IV only. So what is the correct answer to this question? Now, for us to fully understand this question and be able to take very good care of it, we need to first of all know the factors that determine the solubility of gases. What are the factors that determine the solubility of gases? So for us to do this very well, we need to know the factors that control solubility of gases. Now, when you check through your textbook, you're going to find out that some of these factors are, number one, very, very importantly, for gases, you have pressure. Pressure is a very, very important determinant of the solubility of a gas. Then number two, you have temperature. Temperature determines both the solubility of gas and that of solids, very importantly. Now, very, very importantly, you need to know that the nature of the solvent, like some gases are soluble in water, whereas some are not. So, nature of the solvent is also very, very important. Nature of the solvent. So, you have a solvent like water can dissolve HCl, and it can also dissolve ammonia. So this one will give us a basic solution. When it dissolves in water, this one will give us an acidic solution. Hydrogen chloride will give us an acidic solution. So if you have the solvent as water, it will very much affect the solubility of any of these gases. So these are the three major factors that affect the solubility of gases. Solubility of gases is highly dependent on the temperature, and solubility of gases the solubility of gases is highly dependent on pressure. It's a function of its pressure, and as the temperature is increasing for gases, the solubility will decrease. Whereas for solid, as the temperature increases, the solubility increases. So these are the three major factors, and from the options you can see that option D takes care of this because I is nature of solvent, I is temperature, IV is pressure. So these are the three major things that the solubility of gases depend on. So provided you already have a solute, in this case the gas, solubility will now depend on these three other things: nature of solvent, temperature, and pressure. So the right option is D. Thank you. Yes, welcome. Let's look at this question number 7 for JAMB past question chemistry 2018. Which of the following statements is correct about the periodic table? A. Elements in the same period have the same number of valence electrons. B. The valence electrons of the elements in the same period increase progressively across the period. C. Elements in the same group have the same number of electron shells. D. The non-metallic properties of the elements tend to decrease across each period. Now, for us to understand this question very well, we need to know what the periodic table is and how it is arranged. Now, we know that the periodic table is the arrangement of elements according to their atomic numbers. And basically, they are arranged into groups of 1, 2, 3, 4, 5, 6, 7, and finally 8, which is actually group O. So that is the groups of the periodic table. Now we have what we call the period. And you actually have periods 1, 2, 3, 4, 5, 6, 7. So you have 8 groups and 7 periods. So that is what we have as the periodic table. Now, in this periodic table, you have the arrangement of elements according to their atomic numbers. So that here we have hydrogen. So this is how the periodic table looks. This is a rough sketch of what the periodic table is. So you have hydrogen there. Then in period 2 you have lithium and beryllium. Whereas on this other side you have boron, period 3 of period 1 of group 3. Then under group 4 we have carbon, we have nitrogen, we have oxygen, we have fluorine, and we have neon. Sorry, this is actually supposed to be in 2. Supposed to be in this period 2 actually. So they're supposed to have boron, carbon, nitrogen, oxygen, fluorine, and neon. But we're supposed to also have helium here. And in 3 we're supposed to have sodium, magnesium, and on this other side we have aluminium, silicon, phosphorus, sulfur, chlorine, argon. Here we're supposed to have potassium and calcium. So that's about the first 20 elements in the periodic table. So I want you to notice something. This is the groups, group 1, group 2, 3, 4 down. So all the elements in the same group have the same number of valence electrons. So what are the characteristics of the periodic table? Number 1 is that elements in the same group, like this hydrogen, lithium, sodium, and potassium, all of them have the same number of valence electrons. Elements in the same group have same number of valence electrons. Now number 2, elements in the same period. These are the periods, period 1, 2, 3 to 7. Elements in the same period have the same number of valence shell, not electron, valence shell. Like this one, if this one has only K, this one will have only Km, this one will have KML. So the valence shell, that is, if you have something like sodium, you can have this. This is the first valence shell. This is the first shell, this is the second shell. So, and this is the third one. So we have 1, 2, 3. That is K, L, M. So you have L before you have M. K, L, M. So that is how you have this shell. So if you are in the same period, all of them are going to have 1, 2, 3, or only 1, 2. So the valence shell has to be the same. Then another thing that we should notice there is that these two are metals, sodium and magnesium, metal. But when you go to this side, you start seeing non-metals. Sulfur, you see, these are non-metals. Here we also have potassium, calcium, metals. If you start going this side, you start seeing some non-metals like bromine. Under group 7, we have bromine here. So non-metallic property tend to increase towards this side from left to right. So because it tends to increase, but here they said decrease. So that makes this option not to be right. That the non-metallic properties tend to decrease. It's not true. Because here you mostly have metals here, and this other side you have non-metals, fluorine and chlorine. Now, elements in the same group have the same number of electron shell. That is not correct, because we say elements in the same group, period, have the same number of valence shell. So this cannot be correct. You cannot have the same number. It's actually period I have. Now this one, elements in the same period have the same number of valence electron. This is wrong, because it's only elements in the same group that has the same number of valence electron. But you see this B, the valence electrons of the elements in the same period increase progressively. That is true. The valence electron for sodium is 1, magnesium is 2. So as it is going here, is increasing. Aluminium is 3. You understand? The same thing here. Lithium, the valence electron here is 1. That of beryllium is 2. Boron is 3. Carbon is 4. So the valence electron is actually increasing progressively across the period. That makes option B the right option. So you can see I took time to draw this, so take note of this. The periodic table for the first 20 elements. Periodic table is actually the arrangement of elements according to their atomic numbers. And you can see we have 7 periods and 8 groups. Elements in the same group have the same number of valence electrons, whereas elements in the same period have the same number of valence shell. And non-metallic property tend to increase from left to right of the table, as well as the number of valence electrons also increases from left to right across the period. Thank you. Yes, let's look at these JAMB past question chemistry 2018, question number 8. The boiling of fats and aqueous caustic soda is referred to as A. Hydrolysis, B. Esterification, C. acidification, D, saponification. Now, if you look at these options, you see that basically we know the meaning of hydrolysis, which is when you want to get something with water. Esterification, the reaction of ethanol with acid to form esters. Acidification, getting something with an acid. Then saponification is the hydrolysis of fats and oil with caustic alkali to yield propane 1,2,3-triol and the corresponding sodium and potassium salts of the component fatty acids. And these salts are actually the principal constituents of soap. So saponification is the process of producing soap by hydrolyzing it with fats, by hydrolyzing the fat with caustic soda. So the process here is actually saponification when you look at these definitions. So I'm gonna state the definition of saponification. Saponification, very, very importantly, is the hydrolysis. You can see this topic in organic chemistry 2. Hydrolysis of fats and oils with caustic alkali. You can see this in the definition given up there, making saponification the right answer. Hydrolysis of fats and oil with caustic alkali, yielding or producing propane 1,2,3-triol and the corresponding sodium and potassium salts of the component fatty acids. So saponification is actually used in soap production. So the salts of these sodium and potassium, they're actually the major component of the soap. So we use saponification for soap production. So in saponification, what happens is actually you have your fat or oil. In this case, we are using fat. So fat or oil plus caustic alkali. In this case, we are using caustic soda, aqueous caustic soda. So if you have these two combined, you're going to have soap. And you know that soap is actually the sodium and potassium salts. That's the soap. Then what else do we have? We now have what we call propane, 1,2,3-triol. So that's how you produce your soap. So that's how soap is produced. So this is the process of soap formation, saponification. And that makes the right answer to this, saponification. Thank you. Now let's look at this question number 9 for JAMB Past Question Chemistry 2018. Which of the following pairs of substances will react further with oxygen to form a higher oxide? A. CO2 and H2O. B. NO and H2O. C. CO and CO2. D. SO2 and NO. So which of the following pair of substances will react further with oxygen to form a higher oxide? Now, what are higher oxides? If we want to understand this, we need to know what higher oxide are. What are higher oxides? Higher oxides are compounds with greater proportion of oxygen. So any compound in which there is greater proportion of oxygen. Like now you have H2O, which is a normal neutral oxide. Now you have also H2O2, which is hydrogen peroxide. This is a peroxide. So this is a peroxide. Specifically, this is hydrogen peroxide. So this is a higher oxide because there is more oxygen here. This O2, this is normal O. So this is a neutral oxide. You should know that we have neutral oxide, we have higher oxide, we have basic oxide, we have acidic oxide, the ones that are from non-metals, basic, the ones that are from metals. This one, they are from non-metals, and they also form acidic solutions. This one form basic solutions. So these oxides, there are also what we call amphoteric oxide. You need to know about this as well. These amphoteric, they can behave as acidic oxide or basic oxide. Whereas neutral oxide, like H2O we have. But we also have hydrogen peroxides, and we have also other higher oxides. So you need to take note of all these types of oxides. But here in this question, they are asking us which of these pair now will react further with oxygen to form higher oxide. So there are higher oxides like this peroxide. Whenever you have something like this, there is disproportionate number of oxygen. Oxygen is a higher proportion. So you can see that you can actually get about this by having more oxidation of the normal oxides. When you oxidize them more, when they have more oxygen, they can form higher oxides. So which are the oxidation agents here that can help you to have such greater amounts of oxygen? If you look at this, you see that you have CO2, this is an oxidizing agent, and O2. So this can do it. This does not have enough oxygen in it. This does not have. This actually reduces. It can reduce oxygen, the CO2, the CO. Like the CO, when you inhale it, it can reduce the oxygen in your body. And this also has lesser, though this one has plenty oxygen. So you can say that this is an oxide. This is also a good oxide. So these two can actually oxidize something that has normal oxygen into higher oxide. So I think option A is a suitable answer for this. D would have been because of SO2, but considering NO, so that is why I picked this option A. Thank you. Now let's look at this question number 10 for WAEC past question chemistry JAMB 2018. In the preparation of oxygen by heating KClO3 in the presence of MnO2, that's manganese 4 oxide, only moderate heat is needed because the catalyst acts by A. Lowering the pressure of the reaction, B. Increasing the surface area of the reaction, C. Increasing the rate of reaction, D. lowering the energy barrier of the reaction. So what happens with the catalyst? When you add a catalyst to a reaction, what happens is majorly one thing: to lower the energy barrier of the reaction. That's what happens. So this is a direct answer. D is the answer to this problem. Because what actually happens whenever there is a catalyst added to a specific reaction is that the energy barrier is lowered. So you have a reaction, a normal reaction that would have gone like this. So you now have it to go like this. So the energy barrier is reduced. This height is reduced to this height. So that's what happens. That is the effect of catalyst. Whenever you add a catalyst to a reaction, it reduces the energy barrier, making it so that you don't have to suffer so much to get to the next level. You don't have to suffer so much to move from the reactant side to the product side. So that energy that you need to have in order to make this passage from reactant to product is reduced. So that is why you add a catalyst to reduce the energy barrier. So it's none of this. It cannot be to reduce the pressure. Catalyst does not go to affect the pressure or the surface area of the reaction, but it does reduce the energy barrier so that with lesser energy you can achieve what you want. Thank you. Now let's look at this question number 11 for JAMB past question chemistry 2018. Methanoic acid mixes with water in all proportions and has about the same boiling point as water. Which of the following methods will you adopt to obtain pure water from a mixture of sand, water, and methanoic acid? A. Fractional distillation. B. Filtration followed by distillation. C. Neutralization with sodium hydroxide followed by distillation. D. Neutralization with sodium hydroxide followed by filtration. Now, whenever you see a separation process in which the constituents have the same boiling point, the most ideal method for separation is fractional distillation. Very, very important. So this alone makes this the right answer. Whenever they have very similar boiling point, that is what you use. Like when we have crude oil. In Nigeria, crude oil is our major source of income. So to separate crude oil into kerosene, normal fuel, the PMS, AGO, diesel, and the rest of them, you use a process known as fractional distillation. Why do we use fractional distillation to do this? Because they have close boiling point. They have close boiling point. They have similar boiling points. So that's why you do that. And in this case, you're having something that is having the same boiling point. So you need about the same. Not actually the same, about the same. It's hard for you to have two substances of the same boiling point. So if they are about the same, that means they have close boiling points. Then the best option is fractional distillation. Filtration followed by distillation. You can filter out sand, but you cannot use ordinary distillation to separate water and methanoic acid because of their similar boiling points. Neutralization does not have anything to do with it. It's why you neutralizing with sodium hydroxide, so it makes this not to be the answer. Neutralization was followed by filtration. and this is not also a very good answer. So the right option is fractional distillation because they have about the same boiling point. So fractional distillation is what you use. But if you're separating a solid from liquid, you can easily use. If you're separating a solid from liquid, you can also use filtration for this. But fractional distillation does it because at the right temperature, what is going to happen is that the one with lesser boiling point will go out first. Let's say if it is either methanoic acid or water, it goes out first. Then the next one, which is water, goes out if it is having lesser boiling point. Then you have your sand remaining. So you have these two components go out, then you have your sand remaining. So when the first one goes out, it is collected. And the second one is going out, it is collected differently too. Then you have your sand left. So the best way is to use fractional distillation. Thank you. Hello, welcome. Let's look at this question number 12 for JAMB Past Question Chemistry 2018. A quantity of electricity liberates 3.6 grams of silver from its salt. What mass of aluminium will be liberated from each source by the same quantity of electricity, given that aluminium is equal to 27 and silver is equal to 108? Option A, 2.7 gram, B, 1.2 gram, C, 0.9 gram, D, 0.3 gram. Now, whenever you want to solve the problem of electricity and the position of metals, first of all, you need to know the number of valence electron or the number of electron needed for such action to occur. So let's say for silver, what do we have for silver? We're going to have silver is plus. So we're going to have one electron because it's just one valency, then you have your normal silver. So once there is this, you have the deposition of your silver, just one electron. So 1 mole of electron in this case. But in aluminium, what do we have? Aluminium has 3 valence electrons. So we have aluminium 3 plus. So we actually have 3 moles of electrons in order for us to get our normal deposition of get our aluminium liberated. So if you want to liberate silver, we have just 1 mole of this 1 electron, 1 mole of electron. Here we have 3 to liberate aluminium. So how do you go about solving this? So for the first one, where we have silver, we have that 1 mole of electrons, 1 mole of electrons liberates how many? It actually liberates 108 of silver. This is where we got the 108. So if 1 mole liberates 108, now how many moles, x moles, will liberate 3.6? So the quantity of this electricity we are talking about is actually x mole. So you have 1 mole liberating 108, x mole liberates 3.6. So make x the subject of the formula. You have x to be equal to, you cross multiply, x to be equal to 3.6 all over 108. And this will give you 0.033. So if you do 3.6 over 108, you have 0.033. So this is the quantity of electricity that we are talking about. So this quantity of electricity, how many grams of aluminium will it give? But from this our initial equation, we can see that 3 moles is actually 3 moles because of this 3. For silver it was 1 mole because here is 1. So for this aluminium, 3 moles of electrons is going to liberate how many? It's going to liberate 27. You know, here it was electricity, which is what 0.033, as we have here, we now liberate what gram? X gram of aluminium. So if you make S gram the subject of the formula, you cross multiply, you're going to have that. You're going to have X gram to be equal to 0.033 times 27 all over 3. That's when you cross multiply. You have 0.033 times 27 all over 3. So if you do this calculation, what are you going to get when you press the calculator? If you press your calculator, you see 0.033 times 27, which is going to give us 0.891, divided by 3, which will now give us 0.297. So if you make this calculation, 0.033 times 27 all over 3, what are you going to get? You're going to get 0.297. So this is the mass that will be liberated, 0.297. And this 0.297 is approximately equal to 0.3. Because this is 9, so we can approximate this to 0.3 gram. So the right option is going to be D, 0.3 grams. So note the way we calculate this number of moles of electrons needed to liberate this. You already know by checking the valence electrons. So it actually gives what you have here, the number of moles you have from the normal equation gives you the amount here for the atomic mass. So that is how you go about solving this. So take note of this, then do the appropriate substitutions, and you get the correct answer. Thank you. Yes, let's look at this question number 13 for JAMB Past Question Chemistry 2018. Suitable reagents for the laboratory preparation of nitrogen are A. Sodium dioxynitrate 3 and ammonium chloride, B. Sodium trioxynitrate 5 and ammonium chloride, C. Sodium chloride and ammonium trioxynitrate 5, D. Sodium chloride and ammonium diazonitrate 3. So what is the correct answer? Now, if you check the textbook, chemistry textbook for under nitrogen and its compounds, you will note that the laboratory preparation of nitrogen is actually from, there is laboratory preparation of nitrogen from ammonium dioxynitrate 3. So how do we come about this? So like I said, this is the lab preparation for nitrogen. Laboratory preparation for nitrogen from ammonium diazonitrate 3. But how does this happen? This actually happens by using a mixture of sodium dioxynitrate 3 and ammonium chloride. And this mixture is actually done in the ratio of 7 is to 5. And this mixture is done what? It is heated to yield. When you heat this mixture, you will now yield ammonium dioxonitrate 3. This ammonium dioxonitrate 3 in turn decomposes to produce nitrogen and steam. So you see the way nitrogen is produced from ammonium dioxonitrate 3. But how the nitrate 3 come to be? By having a mixture of sodium dioxochloride. That's how you produce this. So once you have a mixture of sodium dioxonitrate 3 and ammonium chloride, you produce ammonium dioxonitrate 3, which can easily decompose on heating to produce nitrogen. So you can see here we have sodium dioxonitrate 3 and ammonium chloride, and that makes option A the right answer, because the mixture of sodium dioxonitrate 3 and ammonium chloride in the ratio of 7:5 produces ammonium dioxonitrate 3, which decomposes upon heating, or which decomposes to give nitrogen and steam. So that is the laboratory preparation of nitrogen, and you can find this under nitrogen and its compound. So that's what happened. In terms of equation, you can actually have it as sodium dioxonitrate 3, which is actually aqueous, reacting with ammonium chloride, which is also aqueous, to form ammonium dioxonitrate 3, which is aqueous, and sodium chloride, which is also aqueous. So this very ammonium dioxonitrate 3, which is aqueous, then further decomposes to nitrogen, which is what you're looking for, gas, plus your steam through H2O, which is liquid. So that's how you get about the laboratory preparation of nitrogen. Thank you. Now let's look at this question number 14 for WIAC Chemistry JAMB Past Question 2018. The number of electrons in the valence shell of an element of atomic number 14 is A 1, B 2, C 3, D 4. Now you have to know how to draw the electron shells for the electronic configurations of elements given their atomic number. So now you're given the atomic number of 14 and you're told to draw in order for you to find the number of valence shell electrons. So you have to have the first electron shell, which normally had just 2 electrons. Then subsequent electron shells have 8. So you now have to count out the number of atomic numbers in the atomic number. So you have 14. So you have 1, 2. This one should have 8. So you have 1, 2, 3, 4, 5, 6, 7, 8. 8 has completed it. But is it up to the number of atomic number here? Here is 14. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's still 10, remaining like 4. So you have to have another electron shell, but this time around it will not be up to 8 because what is remaining is just 4. So you have 1, 2, 3, 4. So if you count the total number of electrons, it should be equal to the atomic number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 of it. So it's now equal to this. But note that the inner shell must have only 2. Other electron shell will have 8, 8. So the valence shell is the last shell. So this is the last shell. So, and this has completed the normal atomic number, which is 14. So how many electrons are on this valence shell? We have only 1, 2, 3, 4. So that makes D4 the answer. So let's say this has an atomic number of 13. You know, what would have been here would have been 3. If we had 12, what would have been here would have been 2. If we had 11, it would have been 1. If we had 10, it would have been 8. Because of this valence electron would have been gone. It will be remaining this to give 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the valence electron would have been 8. So, but for 14, it is 4. And even it's 15, we would have added extra 1 here, making it 5. If it is 16, it would have been 6. If it is 17, it would have been 7. If it is 18, it would have been 8. But if it is 19, you would have now added another shell and count that 19, 1. So the valency would have been just 1. So take note of this. So the right answer is 414. Thank you. Hello, welcome. Let's look at this question number 15 for JAMB Past Question Chemistry 2018. What volume of oxygen will remain after reacting 8 cm cube, 20 cm cube of, is it A, 10 cm cube, B, 12 cm cube, C, 14 cm cube, D, 16 cm cube? Superscript, all the threes on the same cubes are superscripts. Now, how do we solve this? This is a very simple one to solve because first of all, we need to write the equation of this very reaction of oxygen and hydrogen. So if you have hydrogen, which is H2 gas, reacting with oxygen, which is O2 gas, you know you are going to have H2O, which is water. Now, how do you balance this? You have 2 hydrogen here, 2 hydrogen here, 2 O2. So how do you make this O2 2? You are going to put 2 in front here. But now the head is now 4, so we have to put 2 here. So you can see the ratio here, 2 is to 1. Then on this other side, we also have 2. So now, anytime you're having 2 of hydrogen, you're having 1 of oxygen. Therefore, if you have 8 cm cube, 8 of oxygen, you're supposed to actually have 4 of oxygen, because this one is always half of hydrogen is always oxygen. So when it was 2, this is 1. So when it's 8, this should be 4. But in this time around, they are saying if you react this 8 with oxygen, which is supposed to take off 4, but here we're having oxygen 20. So how many will be remaining? So it's going to be 20 minus this 4 that is already taken up to give us 16 cm cubed. So the answer is D, 16 cm cubed. So very simple, you have to write the equation, and you have to deduce what your answer is from the equation. Thank you.